Okay, let's begin on question number 7. Let's move to question number 7 on the whiteboard, please. Okay, the diagram shows a part of the graph y equals to 18 over x and the normal to the curve at 6, 3. So this normal meets the x-axis at point R, and then the point Q is on y-axis and the point S on the curve, such that PQ and SR are parallel to the y-axis. Okay. And then find the equation of the normal at P and show that R equals to the point 4.5. Okay, how do we do this thing and what is this normal? Okay, a normal is a line which at this point, see there's a tangent, right? Tangent is the kind of like the line that only touches the point P around that neighborhood, at point P, touches the curve at point P only. So this red one is a tangent. So the line that is perpendicular to the tangent, which is 90 degrees like that, this is called the normal. So tangent and normal, that's the relationship. They're perpendicular to each other like that. So we find the tangent first and then the gradient. That means perpendicular is the normal. Okay, now, so let's take a look at how to find that. So that means it's obvious that, okay, let's rewrite the equation of the curve first. So y is given as 18 over x, and we need to turn it into the algebraic form, polynomial form. So 18x to the power of -1, so that we can differentiate. And the reason why we want to differentiate the curve is that dy dx. So, so -1 times in front, 18, then x -1 like that. Aha. So in other words, the dy dx is just negative 18 over x squared. Okay. So just the meaning of the dy dx. So the dy dx at, we have to evaluate the dy dx at x equals to 6. Because at P, that means same as evaluating it at x equal to 6, because the value of x is 6. And dy dx here is the function of r. So that means negative 18 over, only change to 6, let's say 6 squared. Then we can easily see that this reduces to -1 over 2, isn't it? Okay, this is -1 over 2. This is the, what is this? This is the gradient of tangent. Okay, so let's say we call it M1, but I write the word here. This is the gradient of tangent line, the tangent line at P. Okay, now the perpendicular means that M1 multiplied by M, let's say just put the letter M or M2, must be -1. This is the meaning of perpendicular. Okay, perpendicular, the relationship, the tangent relationship, let me see the other tangent, is that the two lines have the product of the gradients is -1. Now, what is this M? M is the gradient of normal. Okay, gradient of normal line. That means in this case, M can also be written as the gradient of PR like that. These are different styles of writing. Okay, let's try to find the gradient of M then. So this is M. Just by writing it, you can see. So this is -12, as we just proved just now from here. Look at the box there. And then this is -1. So when you solve this or just rewrite this, you would see that the value of M is just 2. Oh, so the gradient of the normal is 2. So to find the equation of the normal, so let's find the equation of normal. Okay, to find the equation of normal, we just can use the normal way, the few ways. Let's say I do the y minus y1 equals to mx minus x1 way. So x1 and y1 are the known points on the curve that is on the normal. So the normal goes through the point P. So this can be chosen as 6, 3 for the point normal. So y is the general point. So y minus 3 equals to the m is from here. So this is the 2. And then bracket x minus 6. So this is how we determine it. Okay, so then y equals this is 2x minus 12 plus 3. Or finally, we get the equation of normal because it's one of the question, the part of the question. So y equals to 2x minus 9. Aha. Okay, then they say show that the point R is half the 4.5, 0. So at R, you can see that the normal goes through the R at R is that the value of y is equals to 0. So that means put y equal to 0 here, and then you get 2x minus 9 is 0. Or in other words, x is 9 over 2, or that's just 4.5. Oh, so then we get the second answer, which is the value of R is definitely 4.5 and 0. The x value is 4.5, y value is 0. Okay, so we already solved for this. So let me just clear this one. Close. Okay, let's do the second part. So they say show that the volume of the solid for space obtained when the shaded region PQRS is rotated through 360 degree about the axis is 18 pi. Okay, how do we do that? So the idea is to understand that, say the volume of rotation, volume of the solid. Okay, see, the reason sometimes they ask to do the earlier part of the question, because it is linked to the next part. This is 4.5, this is 6. So we're taking the value of xn for these both places. That's the meaning of the parallel line. If you're wondering parallel to the y-axis, that's what it calls us. That means S and R have the same x coordinate, and P and Q have the same x coordinate respectively. So the formula of the volume of revolution will tell that pi of y square dx along the, what we say, the limits of a and b. That means a general sketch would look something like this towards the x-axis, dx. So you want to rotate this 360 degrees, just take pi y square dx of this curve, this is the curve y. Yeah? Okay, so it's a very similar drawing here to the standard drawing. Okay, so let's try to substitute and calculate this place. So this part becomes, take out the pi is just a constant. So you can see that the value of a is 4.5 and b is 6. So the 4.5, I'm just going to write it as 4.5. Easier to write that, so to 6. And then the y square, okay, this is dx. Please take note, the y square, let's say I do in the side here, because lazy to calculate there and write again everything. So y is 18 over x, this is given from here. And then we can just square the whole thing. So we get 324 over x squared. Aha. Or in other words, if you want to write it in the polynomial form, because when we do some integration, it's easier. So let's write it like that first. So this is 324 and x to the power of minus 2. Aha. So on the next slide, what we need to do is, this is pi. We need to integrate. May take out also the constant, because this is the advantage of like 3 to 4 is a constant there of integration. You can just take out the constant 3 to 4 like this, and then put the big block for the integration. That means in the bracket here, what I'm doing is by removing the 3 to 4, we're just integrating x negative 2 dx. Please take note. So when you integrate this, you just plus 1, which is like negative 2 plus 1. And then you divide by that, isn't it? I mean, negative 2 plus 1. So you can easily see that this reduces to negative x to the power of negative 1 and then negative 1 over x. Okay, so this is the meaning. So if you're lazy to do it there, you can do it in the side like that. You can just leave it like that. Or even if you do it in your mind and at this level, straight away just write negative, negative 1 over x can also. There's no reason to show every detail, because at this level they know that you know how to integrate. So you can just straight away even write like that, as long as it's correct. Okay. And then now what we need to do is we just need to substitute the integral limits for this definite integral. So therefore, that would mean that, so I put this bracket here. So you put the x equals to 6 first. So you get negative 1 over 6, then subtract in the bracket negative 1 over 4.5 by substituting the two limits. And then it doesn't have a constant because of the definite integral, because that part will cancel out. Okay. Okay, so there we have it. This is 3 to 4 pi. Aha. And in the bracket, this part now, just substitute put in the calculator. Like evaluate in the calculator, sorry. So this becomes negative 106 plus. Yeah, 1 over 4.5. Just put in the calculator, hit the fraction button. You would see easily that it should be 1 over 18. So 3 to 4 is actually a perfect square, but now just divide in the calculator and of 18 itself, then you realize that the answer is just 18 pi unit cube as required. Ta-da-da. Okay, so that's how we find this answer. All right.